Today I'm presenting AWS security for front-end developers. My name's Chris Miller. I'm born and raised in the South Bay. I've been living in Santa Cruz County for the past 20 years. Recently relocated to San Jose, so a little shorter commute today. I consider myself an AI engineer. You know, that's kind of the label that I think a lot of us are beginning to use. I've been doing software development and Linux, Unix, AWS for many, many years. Boat captain, like not officially, you know, I don't have like a certification, but one of my hobbies on the off time. And also fortunate to have been brought into the AWS Heroes community, where I'm rubbing shoulders with many giants, and AWS has done a great job of building community, hence why all of us are here today. Okay, so I wanted to poll the audience. How many of you consider yourself to be a front-end developer? All right. How many of you consider yourself to be a full-stack developer? Okay. Who do you think has a harder time with security? A front-end developer? Show of hands? Or a full-stack developer? Okay, interesting. This is a good topic for discussion last night. Okay, so today I wanted to share some experiences and pass on some knowledge about common security mistakes, because securing your software applications is hard, right? Do you ever really feel like your application is 100% secure? Do you wake up at night thinking, I must have overlooked something, I don't know what it is, right? It's very unsettling feeling. So today you'll learn some of the common mistakes and how to avoid them, and best practices to lock everything down. So why this matters? Because at the end of the day, security falls on you. Even if you're not a security expert, it's your application, it's your code. If it gets hacked, if it gets compromised, all eyeballs are on you. And I heard something recently, nobody is gonna fault you for being responsible for an outage or a mistake, but they are very much going to look at how you respond to that taking ownership, analyzing what happened, remediating it, doing what you can to make sure that something like that can never happen again. So when the day comes, I don't think it's an if, it's a when, you know, it's just important for you to jump up, take that ownership role, and resolve the issue. Experienced engineers make mistakes. I've been doing this for a number of years, and you know, nobody is impervious to making errors. Things are getting more complicated, not less complicated. The types of attacks are growing in sophistication. You know, AI is certainly can help the script. You know, it used to be the script kiddies that download the scripts. Now you can just use AI to build scripts to make attacks. And the cost of these breaches is increasing. So I looked up a stat. IBM reported that in 2024, the cost of data breaches was $4.88 billion, up 10% from the year before. So I'm curious, what is the worst software security breach that you were aware of? Anybody? Well, I'm sure this question is a little bit ambiguous, but one that is always stayed in my mind was a situation with leaked access keys. A company called CodeSpaces had a hosting environment. They touted it with a lot of redundancy and backups. And so in June of 2014, they had a denial of service attack launched on their systems. And the hackers had demanded some ransom, and CodeSpaces determined that their control panel had gotten compromised. And so they locked that down, and they thought they were in the clear. They didn't think any access keys had been leaked. And the next day, the hackers went in and they deleted everything. All the customers' data, all of the backups, all of the redundancy that their marketing materials claimed they had, and the CEO had no choice but to shut the company down that day. So I think this is probably one of the blaring instances of what happens when an access key gets leaked. And it can happen accidentally. It even happened to my team. I had a client contact us and said that he'd gotten notified by AWS that there was a high volume of emails being sent out. And so I went into the account and poked around and got some email logging on and determined that it was spam. And then I went through CloudTrail and determined that the access key for one of our developers had been used to spin up this infrastructure. I'm like, well, wait, how does that happen? You know, we're not using these keys for any kind of access within the application, at least that I was aware of. So it turns out that, here, my personal story. So, you know, obviously, you know, jump in, I revoked the key access, preserved all of the infrastructure that had been spun up, you know, to be able to report to client, you know, this is what happened, you know, the timeline, all of that kind of stuff. But then we had to go in and figure out, well, how did this happen? And with all of our code, we use code scanning tools. There's Code Guru on the AWS side. There's a tool called Snyk, S-N-Y-K, that goes into GitHub and it reviews our code bases. And it looks for stuff like access keys. Well, there were no access keys in the code. What had happened was the key was used as part of the build process in deploying the application, and the developer naively thought this was required for this deployment access, but didn't realize that Webpack had actually taken that key and put it into the code. And to add insult to injury, that key was available even if you weren't logged into the app. So anybody randomly could have gotten to it, and I'm surprised how long it was out there before something happened. Because there's stats that say that a leaked key in like a Git repo can be detected within as little as 60 seconds. It's just crazy how quickly. Like, the analogy is you drop your keys as you're walking down the street and somebody runs up and picks them up. You know, it can happen that fast. So anytime you have a security credential or a key that is exposed, for no matter for how short a period of time, you really need to consider that that key is compromised and take appropriate action to replace it. So with that in mind, we found that the .env had the key in it. That was used for the build process and it had gotten published. And it turned out that we were using a feature that wasn't directly supported within the application platform, and so it required some escalated privileges to be able to do some user management. And so we went through and implemented the proper authentication, and thankfully, the only thing that happened was that some spam email got sent, because as we've seen, it could have been much, much worse. So mistake number one is God mode. Whenever we engage with a client that has an AWS account, of course, they have to give us access. And so a standard practice, not a best practice, but a standard practice is we get an IAM account and we get some privileges associated with it. And when you're going into a new account and you need to touch a lot of different things, maybe you don't have a finite list, you know, all too often we're just assigned administrator access so we can get in and do whatever we need to do. And with console access, that's fine, right? If you got 2FA, single person accesses it, you can get into the account, do what you need to do. But the second thing that often happens is developer goes in, generates an access key. That access key has the same privileges as the entire account. And if that access key gets leaked, just like this previous situation, then there's full privileges there. So one of the patterns that, well, let me continue on with this. I think part of this is we're always in a hurry. You know, you get a contract, you want to jump in, you want to get the work done. You don't want to go back and forth with the client like, can you add this permission? Can you add this permission? Because it's a big time waster, right? But there's some caveats to this, because you end up with accumulating technical debt, because having full access sometimes will mask types of permissions considerations that you would need to make in the course of developing your app, right? Because everything just works. And if you, at the end of the project, you go back and go, oh, okay, I want to kill the admin privileges on that key, then a bunch of stuff breaks. And then you start giving it the different permissions, and you just get this never-ending list of bugs that you could have resolved through the development process rather than going in at the end and having to refactor everything. And my favorite adage from a guy named Uncle Bob Martin, who wrote the book Clean Code, later equals never. You know, we always talk, oh, I'm going to get to that later, but do we set a reminder? Do we actually go do it? You know, more often than not, you're not going to do it. So you just have to be proactive from the beginning. Okay, so best practice one is privilege separation. So what I like to see at a bare minimum is that when we're provided with access to an account, we have our administrative privileges console only. Then we can set up a second user that's just developer only. It has an access key, and it's only assigned the minimum amount of privileges needed. So we need access to an S3 bucket, Lambda functions, whatnot. Only assign those kinds of roles and policies to that user. And largely, we're just using this for CLI tools. As we're developing, we use AWS CLI to conduct certain operations on the AWS account. But this is not necessary for any kind of modern full stack application. So an advanced use case is the IAM Identity Center. What this does is it allows you to use temporary credentials, and it gives you a lot more granular controls, like using sessions and session timeouts. So this is a much better way of managing this. This is a little bit beyond the scope of the talk. I wanted to focus a little bit more on the application development side of things than necessarily the AWS console side of things. And Mike just gave a great talk in the Hahn Auditorium on Roles Anywhere, IAM Roles Anywhere. So that's a new service to me, a little bit different use case, but it's nice to see that we're having more flexible options that is an alternative to just using static API keys like we've been used to. Okay, proper key management. So some of this stuff may be obvious. I know this is a security conference, but I just want to make sure that everybody's on the same page here. When you generate an access key, you can download it as a CSV. It's sitting in the folder on your computer. You need to send it to a developer. Well, how are you going to do? Oh, I'm just going to Slack that message. Well, that's not really a good idea, because you've now put that key where somebody somewhere technically has access to it. There are a number of different encrypted options that you can use. I'm a big fan of 1Password. That's a way to be able to store passwords and credentials encrypted. You can share them with people. They have to they don't have to have a 1Password account, but they have to authenticate based on their email address. So it's maybe not perfect, but it's certainly a higher level of security. There's another tool called PW Push that's free. You just go to the website, you put whatever text in there, and it generates a link, and it automatically expires. But you never want to include, your username and password in one of these encrypted payloads, or in this case, the key and the secret. You don't want to enclose those together. Some old school ways, or maybe you send through one mechanism, you send a username through an email, and you send a password through a text message, and you force them to update that password. So there are a lot of ways, but, don't be lazy about it. It's super important that you don't send these in plain text. Rotating keys periodically is definitely a best practice. There's nothing by default in the console that's going to remind you to do that. So unless you're going into IAM and you look at your users, you're not going to see that indication of how old that key is. So old school way, you set yourself a periodic reminder to rotate those keys, but that can always be ignored. A modern way is using tools like AWS Security Hub will send you alerts about best practices within your account. And this goes far beyond just the age of access keys. So that's definitely a good built-in tool that you can use. You just have to turn it on. Obviously, never hard code keys. I hope everybody's moved past that. Using gitignore to make sure that you're not committing any kind of sensitive files, and it's not just a .env that might have access keys in it. Depending on the platform that you're using, there are other files that have sensitive information that should never be in Git. I'm a huge fan of AWS Amplify. I'll probably say that more than once today. Between Gen 1 and Gen 2, the file that has a lot of sensitive information has changed names, and so you have to make sure that those files are in your git ignore. And then once you're done with a key, you can go in and disable it. You don't have to delete it. You can turn it off, and if you want to use it again down the road, you can just at the click of a button. So just another way that you can, little steps that can help to increase your security. Okay, broad permissions. Does anybody in this room know what this means? Okay, got some old school people here. My very first tech job was tech support for an internet service provider. And in addition to dial-up modems, if anybody remembers those, I had to support developers that were deploying something called a CGI script. And the frustrating thing about being a new developer is you upload all the files and you run the thing and you get a 500 error and you don't know why. And the sledgehammer way to fix that is you set the permissions to read, write, execute for everyone. And so every time I'd see this helping somebody out, I would have to explain security to them and say, no, you don't need read, write, execute for everyone. You just need it for the owner in this case. But this carries on to today. And so another best practice is the principle of least privilege. And this is something that AWS has been advocating for a long time. So you want to set your permissions, you want to test them, find out what permissions are missing, and then refine them. Now, the problem is, as developers, we're in a hurry, right? There's a timeline, there's a budget. It's easier to just say, well, I'll just go back later and reduce the permissions. The problem is later equals never, right? So if you're diligent about doing this, you minimize access from the beginning, you reduce the risk. Permissions are specific to roles or tasks and not individuals. And whenever you can use temporary privilege escalation or elevation, you're reducing the attack vector because, yeah, the app can do something with higher privileges, but for a very short period of time. All right, authenticate everything. In web applications, on the front end, you can say on each individual page within your app, or even at the component level, if we're talking like a modern TypeScript React type of app, you want to check and see, should this be available to the public, or should it be available to specific users or groups, and which really groups? Which group should those be? But beyond that, within your code, you can restrict access to certain components or fields on the page based on what that group association is. But oftentimes, I've heard people say, well, I protected it on the front end, but your front end talks to a back end through an API. So if your back end is not also protecting that, like a bad actor is not going to log into your app and then try to manipulate the app. They're just going to go straight for the API. They're just going to bypass all these protections that you have in your front end. So you need to make sure that you're using those same permissions on the back end to protect access. And data schemas now allow you to do this. Again, I'm a big fan of AWS Amplify. The Generation 2 product has taken a code-first approach as opposed to a tooling-first approach. So if you're doing Next.js, you can just do your npm create app and start coding away. You don't need to set up anything in AWS. And then when you're ready to start working with backend resources, there's a single command that generates all the boilerplate for Amplify, and it will spin up a sandbox in your AWS account with all of those resources, and it's all defined as infrastructure as code, including this data schema. So there are a couple of key resource files that define this, and so you can define privileges for groups or users down to the table level and possibly even beyond that. So I really like that. As a developer, I don't necessarily have to go in and manipulate things by hand within AWS. Now this infrastructure as code is available to me within Amplify. There's a lot of built-in constructs, but what is not supported, You can use CDK constructs. So all of the infrastructure that you might want to spin up for your app within AWS, you can define that within your Amplify configuration. And I think that's super powerful. Okay, use an identity provider. This is AWS Community Day, so you've probably heard of Cognito. There are a lot of choices out there for doing authentication, but I mean, we are long past the days of building your own authentication. I mean, there are just too many ways that things can go wrong. I mean, I remember the old days of like, well, the session works fine on, you know, Chrome or Firefox, but, you know, on Internet Explorer, like for some reason it's, you know, it's not letting me log in, or it's not keeping me logged in, right? So there are, I feel like somebody from AWS told me once there were like 25 modes of authentication, like all the different things that users have to do. Well, I lost my password. Well, I want you to remember me, or I want you to keep me logged in. So this is just a short list of those modes, and Cognito really handles all of this for you. It really provides frictionless user authentication. In the case of Amplify and React, there's an authenticator component, and you just drop in one tag, and there's your sign up and your login capability. Just, you know, your basic first name, last name, username, password. But then they support, I think it's like 20 or so. There's a standard called OIDC, and there are like 25 standard attributes. So if you want to ask the person when they're signing up for their time zone, you can ask that. Right, because if you have an app that's sending out text messages, you don't want to send somebody a text message when it's in the middle of their night, right? So it's important to know like where they are geographically. Phone numbers, and yeah, it's just, it really works well out of the box. So I recommend, you know, focus your time on building the thing that makes your app unique rather than the authentication process. And it integrates with everything AWS. Again, you know, plug for Amplify, sort of call it a gateway to AWS, because like you can deploy apps on Vercel and Netlify and a bunch of different platforms, and they're great up to a certain point. You know, they have functions, but if you want to do advanced use cases where you want to leverage other things like, I don't know, building an IoT platform, right? Or a video platform, or things where you would, at that point, you would need to rely on some other third party to integrate with the app that you're building at another hosting provider. You know, AWS has so many different services. It sort of checks most of the boxes, and the fact that you can access all of those services right from Amplify, like that's super powerful. Like there's this consistency in the way that you deal with all of the different services and set them up. And so that's something that has really been powerful for my team building advanced apps. So Cognito groups map to IAM roles. You can create a role that it's, what's the term for it? It is, there's an assume role that happens that when a request goes through to access some resource within AWS, the group allows it to temporarily take on that role and to access those individual resources. And it gives you real granular access control, and you can set up multiple groups with different roles for people. So it's not just, well, I have user and manager and admin, right? You can create other groups and then assign them to people based on whatever the scenario is. So yeah, you don't have to, you can be as tightly controlled as you want without giving anybody anything access that they don't need access to. All right, so again, one of the pain points when you're creating these roles is you set up a role, you know what services you're using, you create a policy, and then you go test your app, and you get an error, right? You're like, okay, I got to go add this. And it's like a whack-a-mole, and you're just going back and forth, and you're burning all of this time. This is why people just blow open the permissions, and hey, I'll just deal with it later, right? So there is a tool that's been around for a long time. I think it even has the original AWS branding, which I thought was hilarious, called the policy generator. So you can generate a policy, and then they have a simulator tool that you can test the policies. And so this is the textbook correct way to do things at AWS. I actually, in preparation for this, I talked to a security specialist at AWS just to bounce some things off of, and he mentioned the policy simulator. And I told him, well, I just use Access Analyzer to generate the policy. And he says, that's the fastest way to do this, but technically you should be using the simulator. But either way works just fine. So with the Access Analyzer policy generator, you create your Cognito group, you create your role and attach it. You can do best practice, add the services, or just leave it blank. And then you go in and test your app, and you're going to get these errors as your app tries to access these resources that it's not allowed to access. Then you go back to that role, and you scroll down to the bottom of the page, and you click the policy generator, and it will go look at the CloudTrail logs for all of the resources that were denied access, and it will build the policy for you. And then you just go ahead and save that in your policy, and you're off to the races. It's like the most efficient way to generate these policies. Okay, and with that, secure your apps. That's my call to action for the day. Today we've covered the cost and impact of security breaches, using the principle of least privilege, using temporary credentials, authenticate everything, front end and back end, and check out Amplify Gen 2. Thank you for your time today. Does anyone have any questions? All right, well, I wrapped early. I got a half hour on my timer almost. She's got a mic for you.
Thank you very much for your talk. Your personal story where the access key was stored in a .env file, would you say that that is more the exception or more the typical problem that people run into or need to be careful to avoid?
Well, I think a lot of, historically, and maybe this is we've all done it, right? We put access keys in code because they're like, hey, I'm going to get this going, and then I'm going to take it out later, right? So I would hope that we're at a point where nobody's doing that, but I just feel like we just need to be transparent and just constantly advocate, don't do that, right? Now, beyond that, when you talk about different applications and use cases, why do you need to put credentials in a .env file? Well, it depends on what you're building and what kind of resources it's accessing, right? So if, the default git ignore, I don't think has .env in it necessarily, right? So so we need to be vigilant in terms of making sure that we go into git ignore and say, hey, these things never belong in the Git repository, right? As part of setting up your development environment, so that if for some reason somebody puts a key in for whatever reason, that's not going to get leaked into the repository. So again, the details on the code spaces breach, I ended up hearing from somebody who must have been close to the situation because I did some research on it before the presentation, and I was told details that I had a hard time finding that same information online. And so what I remember hearing is that they had access keys that got put into a repository, and that repository had gotten set to public inadvertently, and that's how the credentials got leaked out. I don't 100% know if that's true, but it's like, oh, hey, it's a private repository, it's never going to be public. Well, until somebody else outside of your control does that because they didn't know that you had keys in there, right?
Yeah, and also don't have your keys. Those type of keys have access to your backups and your backups and stuff too.
Yeah, and I mean, AWS is doing a good job of evolving to the point where they recommend using static keys at all, right? We all have our .aws directory. We've got some profiles in there that have got keys, but if your laptop gets compromised, I mean, I know Macs are great and it's got the secure file vault and all of these things, but it doesn't mean it's impossible for somebody who got a hold of your laptop to get access to these keys. And are you going to remember how many clients' profiles you have in those files? Maybe. Also, another good point is the UK just passed a law that required Apple to open up their iCloud storage to the authorities, which means even if you're not a UK citizen, your data in iCloud is technically available to the UK authorities if they wanted to go in. And who's the UK authority? I mean, so you definitely want to turn on encryption there, right? Another call to action, like turn on File Vault if you're using, or turn on encrypted backups to iCloud if you're using them. So that way, you know, information doesn't leak out again, unbeknownst to you.
Any other questions?
All right, well, thank you again. I appreciate you choosing to spend your time here with me today.